In this video, we'll take a quick tour of the technologies and platforms that we've chosen to work with, and also the tools and accompanying infrastructure that we've selected to work with those platforms. This video is more of a whirlwind tour that for the most part will just list the major technologies and tools that we've chosen at Multunus. If you'd like to learn more, please do write to us with your questions at info@multunus.com. Let's start with the technologies and platforms first. On the server side, most of the work we do is with respect to building and exposing REST-based web service APIs. We'll cover both the language and the web frameworks we use for this purpose, along with the databases that we work with. As regards the client side, we build both web and mobile apps. And on the mobile front, we build mobile web, native, and hybrid apps on the iOS and Android platforms. Let's start by taking a look at the technologies on the server side. We've been relying on Ruby on Rails to build web apps since 2008. While we have traditionally leveraged the whole stack to build web apps, these days we rely on it primarily for building REST-based APIs. These web services are then consumed by desktop or mobile web technologies such as JavaScript and HTML5 or by native mobile apps. Besides the standard implementation of Ruby, which is called MRI, we've also deployed Rails on JRuby, which is a popular implementation of Ruby that runs on the Java virtual machine. Some of the apps that we've built required deep search capabilities, such as wildcard queries, proximity queries, range queries, highlighting, stop words, and stemming. We've chosen Lucene as the fundamental technology for implementing the search component in all of these apps. And we use Solar, which exposes REST-based APIs to access Lucene's features. For some of our internal projects here at Multunus, we rely on Sinatra, which is a much more lightweight web framework than Rails. RSpec is the de facto BDD framework in the Rails world, and it's a standard part of our test infrastructure at Multunus as well. Spork is used to reduce the launch time of RSpec, thereby making it possible to run tests much more frequently. The list on the right are rack servers that we've used in production. A common configuration used to set up new projects is Apache and Passenger. However, we use a combo of Nginx and Unicorn for higher traffic websites. Finally, Trinidad is the rack server that we prefer for deploying JRuby apps. Moving on to databases, we've worked with both RDBMS and NoSQL DBs. We've had the opportunity to work with large databases exceeding millions of records in both types of databases. While we've done quite a bit of work on MySQL in the past, we've now moved on to Postgres. Incidentally, Postgres was the database that received the most amount of attention during the development of Rails 4. Finally, MongoDB and Redis are the NoSQL databases we've used in production. Let's now switch to the client side. This is the list of technologies we use for building desktop and mobile web interfaces. We've leveraged HTML5's features such as WebSockets, local storage, native audio and video in multiple web applications. We've also used HTML5's application cache to allow web apps to work offline. The hardware accelerated transitions provided by CSS3 attributes allows us to implement smooth and fluid user interfaces, which are also very efficient. Building responsive web apps is also much easier with the media query support provided by CSS3. jQuery is perhaps the most commonly used JavaScript library out there. Everything from its selectors to its iterators and cross-browser compatible event handling makes it a natural choice for any front-end web programmer. jQuery Mobile is a cross-platform HTML5 based user interface system built on top of jQuery itself. Its flexible, easily themable design makes it possible to create polished apps quickly. Backbone.js is a model view collection framework that makes it possible to build highly complex and interactive JavaScript applications in a modular and easily maintainable manner. The fact that it's designed to work with REST-based APIs makes it a no-brainer choice as well. Bootstrap, or Twitter Bootstrap as it was called until recently, is a CSS framework that provides a grid system to make responsive design easy. Further, it also provides reusable UI components for building consistent user interfaces quickly. Moving on to the items in the right column, Jasmine is a BDD test framework for JavaScript. JS Test Driver is a test runner that you can use to run tests against different browsers. Finally, Synon.js is a stubbing and mocking library that makes it possible to write tests with fewer dependencies on external services. Moving on to the iOS platform, we have two broad categories of apps here, those that are purely native and secondly, what are called hybrid apps. Native apps are written in either Objective-C or Ruby Motion and then compiled into native binaries. Hybrid apps, on the other hand, have a good amount of their code written in HTML and JavaScript and use a framework such as PhoneGap to run this code within a browser component inside a native container. Moving on to the items on the right, they are all BDD testing frameworks. We've already taken a look at Jasmine and JS Test Driver. Cedar and Bacon are both RSpec style BDD frameworks. While Cedar works with Objective-C, Bacon works with Ruby Motion. The last platform in this section is Android. Just as with iOS, we have purely native and hybrid apps here as well. The pure native apps can be written in a variety of languages including Java, Python, C, C++, etc. At Multunus, we've used Java, C and C++ so far. While Java suffices for the most part, it becomes necessary to rely on C or C++ when higher performance is required. For example, to convert raw audio files into MP3s. We've already discussed PhoneGap in the iOS section. What's interesting here is that the same code base will work pretty much exactly the same in both iOS and Android. This is what makes PhoneGap a very important option to consider while building mobile apps. The downside is that the user interface will not end up being as smooth as that of a native app. As regards the test frameworks, JUnit is the de facto standard here for test-driven development. As regards Jasmine and JS Test Driver, as already mentioned in the iOS section, this is used for test driving the JavaScript code inside PhoneGap. Let's now move on to the tools that we use to complement the technologies that we've covered. These tools are again categorized under 6 different types: dev infrastructure, code analyzers, exception notifiers, NFR or non-functional requirements infrastructure, deployment infrastructure, and finally, server infrastructure. Let's start with what tools are used by our programmers. We've got a standard tool set that we install in all of our dev machines. Since this saves a significant amount of time in training and setup and also allows almost any programmer to work with the same set of tools. Xcode is the default IDE for iOS apps while writing native code in Objective-C. We rely on Emacs and Sublime for pretty much all of our Ruby code for JavaScript and HTML. One of the first things a programmer does when kickstarting a new project is to create what is called a virtual box. The virtual box contains the complete dev setup including the OS, the frameworks, and their dependencies specific to the project being worked on. The virtual box can be saved as an image file and then cloned in as many new machines as required. This avoids the need to set up the whole infrastructure for every new programmer who joins the team. So where does Vagrant come in? Well, we use Vagrant to configure, maintain, and run these virtual boxes. Chrome DevTools are tools shipped with the Chrome browser. These tools include HTML element inspectors, JavaScript debuggers, and performance tools, among other things. All of these are very useful for building the user interface of web and mobile apps. We introduced the concept of technical debt in the sustainable engineering video. Code analyzers are useful for providing frequent feedback on which areas of the code need to be refactored. Code Climate evaluates the code for both code smells and security holes. The weekly report contains a single GPA score. The higher the score, the less the team has to worry about. While Code Climate detects code smells in Ruby code, Plato does the same thing for JavaScript. Plato is open source and free, unlike Code Climate. Exception notifiers alert the dev team when things go wrong in production. The alerts are sent by email. These emails contain context information about the exception. With this info, the programmer can quickly get to the root of the problem and resolve it. However, not all exceptions are critical, and hence, not all of them need immediate attention. It is still important, however, to be able to determine how often the less critical issues happen. If they are found to be more frequent, then the issue is probably more critical than initially noted. Both Airbrake and Airception are hosted services. While Airbrake notifies exceptions in Ruby code, Airception does the same thing for JavaScript. NFR stands for non-functional requirements. The tools on this slide measure the quality of two types of NFRs, performance and uptime. New Relic is an application performance management tool that has capabilities such as performance analytics, server monitoring, and availability monitoring, amongst a host of other features. While New Relic can monitor both the web application and physical resources, we use Monit to monitor all other services running on the server, such as email, the database, queuing systems, etc. Blitz.io is a hosted stress testing tool. The target server, and more specifically, a specific API, can be bombarded with requests originating from different parts of the globe. When this is being done, the team can analyze activity on the server using New Relic and then pinpoint performance bottlenecks in the code. Deployment is the process of installing new or updated code on a server and then restarting it. In the continuous delivery video, we mentioned that this process should ideally be automated end to end. Let's look at the tools required to make this happen. Git is the version control system that we use for all of our code and configuration files, and Jenkins is the continuous integration server. Jenkins is configured with as many projects as we have going on at the same time. For each of these projects, Jenkins is configured to check out the code from the corresponding repository and then to run the tests present in that accompanying test suite. The build pipeline is an extension to Jenkins that migrates the code from one environment to the next, as configured in the pipeline. In a typical scenario, code is first migrated from the CI server to staging and then from staging to production, assuming, of course, all of the tests pass. Jenkins relies on Capistrano to migrate the code and then execute the installation scripts. At the end of this process, all target environments are updated with the new version of the code and ready to be used by the end user. Puppet, Chef, and Moonshine are software that fall into a category called configuration management. All of these tools are used to completely automate the process of setting up a server, sometimes even starting with the operating system and then installing the frameworks and all other services required for the application to run. Finally, TestFlight is a hosted service that is used to distribute beta versions of iOS apps to early adopters. More recently, support for Android has also arrived. Finally, let's look at some of the services providing cloud-based servers on an infrastructure as a service model, or what is called IaaS. We use Heroku for doing quick deployments using their built-in automated scripts. This is sometimes useful for demoing features in the early days of the project. Considering that the load in the early days of the project is close to nothing, Heroku's free tier will suffice for the most part during this phase. AWS, or Amazon Web Services, is a suite of web services. We use two of these extensively, EC2 or Elastic Compute Cloud and S3 or Simple Storage System. EC2 is Amazon's hosted server infrastructure. There are many tiers to choose from. For early stage products, we have found the small instance to be more than sufficient. We use S3 for storing and serving all assets such as images and sometimes videos. CloudFront is a CDN or content delivery network from Amazon that is built on top of Amazon S3. CloudFront allows for faster delivery of the assets by cloning the assets on multiple servers around the world and then intelligently serving the asset from the server geographically closest to the end user. Rackspace is yet another service that provides cloud-based servers. Rackspace is a little pricier than AWS, but we recommend hosting the production servers there because of their remarkable customer service. Thanks for watching. This is the last video in the engineering and technology section. We hope you've now got a good idea of how programmers go about their daily work at Multunus.